Josh, what's one thing that every fluid power professional should avoid?
Back talking to their spouse?
Well, that's for sure. But I was thinking more along the lines of cavitation.
Oh, right. That's a big issue too. Cavitation is one of the most researched topics in fluid power, which is justified because it's both all too common and unfortunately damaging to pumps.
So what can you tell us about it?
Liquids are able to hold dissolved gases in solution, and the gas saturation level within any liquid is dependent on the pressure, the temperature, and the type of liquid itself, amongst other things. Cavitation is literally the bubbles spontaneously formed during conditions which prevent the liquid from holding that gas in saturation, such as a drop in relative pressure.
Why does this make me think of a trusty old bottle of soda pop?
That's a great comparison. Let's think about how this works. To ensure that the pop is fizzy when it hits your lips, the carbon dioxide is supersaturated within the delicious beverage, and the pressure maintains that artificial level of fizz until you opening the bottle. Upon opening the bottle, you can see cavitations at bubbles at work, and they form out of nowhere. The same thing happens in hydraulic fluids, simply as common air is dissolved within itself, but the principle is the same. The problem with my example is trying to translate some harmless bubbles that tickle your taste buds into the damage that can eat away solid metal. Cavitation bubbles themselves do little damage just floating around your hydraulic oil, but rather it's the bubbles when they reach the pressure side of your pump that they do their harm. Cavitation bubbles would rather form within the imperfections on the surface of the metal parts of your pump, such as the lens plate, the cam ring, the vanes or gears, rather than just popping into existence in the middle of the fluid. The damage from cavitation occurs when bubbles make their way around to the pressure side of the pump, where they implode under pressure, creating super hot jets of fluid that pierce the bubble. Because the bubbles are most often located on these metal parts, the little implosions create those jets of heat, little jets that heat up the surface of the metal, and you end up with little pits which destroy the pump's efficiency until it just can't pump at all. Sometimes cavitation is unnoticeable, but if you ever hear a sound like someone threw marbles into your pump, that's probably a result of cavitation.
So we know that cavitation is bad, bad, bad. What are some tips to avoid it?
I've got 7 for you. Ready?
I am ready.
1. Don't use a suction strainer. Suction strainers are installed on the reservoir on the suction line of a hydraulic pump. They are intended to protect the pump from ingesting dirt and filth, which should subsequently protect your pump. However, think about the method in which a suction strainer prevents dirt from entering the pump. It collects dirt across its flow path. Larger particles and other junk get trapped on the suction strainer, but over time it just gets clogged. Most often, maintenance personnel don't even know the suction strainers are there, so they can get overlooked during routine maintenance. When it does get clogged, it causes a slowly increasing levels of cavitation. 2. Ensure your pumps have flooded suction. A pump can create a vacuum at the inlet to pull fluid up a short distance, but excessive pump head height can cause cavitation. A flooded suction condition uses the force of gravity and atmospheric pressure to push fluid into the pump, rather than the pump having to draw it in. With a pump mounted below or to the side of a reservoir, cavitation is nearly impossible. 3. Don't leave rags in the reservoir. It may sound ridiculous of me to offer this as a suggestion, but every hydraulic technician worth their weight in oil counts the number of rags they show up to a site with and leave a site with. If you leave a rag in the reservoir, it will most definitely find its way to the suction port of your pump, starving them and causing cavitation. 4. Properly size inlet plumbing. They recommend maximum velocity for suction strainers at only 3 feet per second, and because of the relative action of fluid being pulled in by the pump already causes a drop in suction pressure, the condition of sucking too much fluid through a small straw will cause cavitation. 5. Use high quality fluid. Synthetic hydraulic fluid has many properties making it superior to standard dyno oil, which has limited capacity to work well outside of a narrow window of operating conditions. Speaking on viscosity alone, thicker oil is harder to pump and is more prone to cavitation. 6. Heat your hydraulic oil. Odd as it may sound, I've seen more industrial machines with tank heaters than mobile machines, but regardless of your applications, heating the oil before the machine startup can also help prevent cavitation due to cold-related high viscosity. Oil doesn't need much time to come up to temperature in most cases, and because tank heaters are typically thermostatically controlled, there is little concern of overheating the oil. And finally, 7, keep your oil dry. This recommendation comes from a specific example of a pump cavitation that I experienced. which could have been prevented if a few of my other tips were also considered. This brutal past winter broke down more than one hydraulic machine, and this particular example occurred on a half dozen machines powered by a 12-volt DC electric power unit. Excessive water saturation within these hydraulic power units caused ice to form on the suction strainers, both cavitating the pumps and imploding these strainers. Yes, these units already had the highest quality Arctic oil on the market, but excessive water saturation was never accounted for. And even thin oil couldn't make its way past the ice forming on the strainers. These units now have heated enclosures, water-removing filter elements, and have had their suction strainers removed.
Sounds like they learned their lesson.
Indeed they have.
Well, once again, thank you for watching, and visit fluidpowerworld.com for more videos.